11th Science, Chapter 4, Chemical Bonding and Molecular Structure, Part 1.
Hello students, I am Madhusina, your chemistry teacher. Watch my YouTube videos, like and subscribe it for further notification. In this video, we will be studying about chemical bonding. As you already know, matter is made up of atoms. Atom is the fundamental unit of matter. Under normal conditions, no element exists as independent atom except noble gases. However, it is observed that some atoms they come closer and stay in the form of a molecular species. That means there is any force acting between these atoms which are holding and keeping these atoms together. So in other words, a molecule is being formed which is stable in nature. This gives rise to a number of questions. What is there between the atoms which keeps these molecules stable? All these atoms are staying together in the form of a single molecule. An attractive force which helps these atoms to stay together is known as a chemical bond.
Let's understand chemical bond by the upcoming video.
Atoms are the basic unit of chemical elements. They contain subatomic particles in their nucleus and in the electron cloud that surrounds the nucleus. These subatomic particles include protons and neutrons, which are located in the nucleus, and electrons, which are located in the cloud or field that surrounds the nucleus. Protons have a positive electrical charge, neutrons are uncharged, and electrons have a negative charge. The number of protons and electrons are equal, so atoms are electrically neutral particles. If we look at a model of the element carbon, which has 6 protons, 6 electrons, and in most cases 6 neutrons, we can see the electrons in simple rings or shells surrounding the nucleus. Each shell represents a different energy level, and it can only hold a certain maximum number of electrons. In chemical reactions between atoms, only the electrons in the outermost shell participate in the resulting chemical bond. In atoms with only one energy level or shell, 2 electrons are required for stability. If we look at helium, which has only one shell or energy level, we see that it is full because it contains 2 electrons. So helium is stable, and there is no naturally occurring compound containing helium. Hydrogen, which also has only one ring or shell, possesses only 1 electron in its shell, so it's chemically reactive. In atoms with more than one energy level or shell, 8 electrons are required in its outermost shell for stability. So neon, which has 8 electrons in its outermost shell, is stable. And oxygen, which has only 6 electrons in its outermost shell, is chemically reactive. Atoms that do have fewer than 8 electrons in their outermost shells will try to share, gain, or lose electrons in order to become stable. This is called the Octet Rule. But there are some exceptions, such as we saw with hydrogen and helium, which have only one energy level.
Normally, 2 basic rules of physics is followed. Opposites attract and likes repel. Nature moves in the direction of least resistance. That is, that process is favorable which requires less energy. Chemical bonding is the process by which elements combine to form compounds. The electrostatic attractive forces between the atoms are strong enough for the atoms to act as single unit. It mainly occurs due to either transferring or sharing of electrons. Watch this upcoming video to get more details.
The interactions of 2 or more atoms mainly occur at the outermost shell or energy level. The consequence of these interactions results in a chemical reaction. In atoms that have fewer or more than 8 electrons in their outermost energy level, reactions occur that result in the loss, gain, or sharing of electrons with another atom to satisfy the octet rule. The octet rule means that elements tend to combine so that each atom has 8 electrons in its outermost shell. This results in the formation of structures such as crystals or molecules. There are two main types of chemical bonds: ionic bonds and covalent bonds. Ionic bonds are bonds where the transfer of electrons takes place. Let's see how this type of bond works. Here we have a sodium atom, which has an atomic number of 11, meaning it has 11 protons in its nucleus and 11 electrons in its shells or energy levels. Shell 1 has 2 electrons, shell 2 has 8 electrons, and shell 3 has 1 electron. And here we have a chlorine atom, which has an atomic number of 17. So 17 protons and 17 electrons. It has 2 electrons in shell 1, 8 in shell 2, and 7 in shell 3. We know that atoms want to have 8 electrons in their outer shell. So sodium can give up 1 electron, and now it has 8 electrons in its outer shell, and chlorine can take that electron from sodium, and that will give it 8 electrons in its outer shell. Since the sodium atom gave up an electron, it has 11 protons, which are positively charged, and 10 electrons, which are negatively charged. This results in the formation of a sodium ion with a positive charge. An ion is an atom or molecule with a net electrical charge due to the loss or gain of an electron. Since the chlorine atom gained an electron and now has 17 protons and 18 electrons, it is a chloride ion with a negative charge. The positively charged sodium ion is now attracted to the negatively charged chloride ion, and NaCl, or table salt, is formed. This is an ionic bond. So, ionic bonding is when an electron transfer takes place and generates two oppositely charged ions. Now for covalent bonds. Covalent bonds are chemical bonds that are formed by the sharing of one or more pairs of electrons by the outer energy levels or shells of two atoms. The four major elements of the body, carbon, oxygen, hydrogen, and nitrogen, almost always form covalent bonds by sharing electrons. So, for instance, two hydrogen atoms can bond by sharing a pair of electrons. Hydrogen is one of the exceptions to the octet rule of having 8 electrons in the outer shell because it only has one shell. Let's look at carbon dioxide, or CO2, which forms a covalent bond. Oxygen has an atomic mass of 8, so 8 protons and 8 electrons, 2 electrons in its inner shell and 6 in its outer shell. So oxygen atoms want 2 more electrons for their outer shell. Carbon has an atomic mass of 6 protons and 6 electrons, 2 in the inner shell and 4 in the outer shell. So it wants 4 more electrons for its outer shell. These fellas can make each other happy by sharing what they have. Oxygen atom number 1 can share 2 of its electrons with the carbon atom, and in return the carbon atom can share 2 of its own electrons with oxygen atom number 1, making oxygen atom number 1 happy. Then oxygen atom number 2 can come in, and like oxygen atom number 1, it can share 2 of its electrons with the carbon atom, and again in return the carbon atom has 2 more of its own electrons that it can share with oxygen atom number 2. So now all 3 atoms are happy. By sharing 2 pairs of electrons in this situation, a double bond has been formed, and